Today I am going to discuss about principles of programming language. In the principles of programming language, now we discuss about the second unit, data types. Firstly, we know that what is meant by data type. A data type defines a collection of data values and a set of predefined operations on those values. Design issues for all data types. First one, what operations are defined and how they specified. It is convenient both logically and concurrently to think of variables in terms of descriptors. Next, what is meant by descriptor? A descriptor is the collection of the attributes of a variable. First one, a descriptor is used for type checking, allocation and deallocation. Second one, static attributes need only be a variable at compile time. Dynamic attributes need to be variable at runtime. Static attributes only in compile time and dynamic attributes need to available at runtime. Next one, primitive data types. Primitive data types are those that are not defined in terms of other data types, common primitive types. First one, numeric types. In primitive data types, first one is numeric data types. Numeric types. Early PL programming languages had only numeric primitive types and still play a central role among the collections of types supported by contemporary languages. In numeric data types, three types of numeric data types. First one integers, second one floating values, third one complex. First one integers. The most common primitive numeric data type is integer. Hardware of many computers supports several size of integers. For example, C and Java allows these. Short integer, integer and long integer. An integer is represented by a string of bits with the leftmost representing the sign bit. For example, C++ and C hash include unsigned integer types, which are types for integer values without signs. In C language, integer data types in sign bits, representing in sign bits. And C++ and C hash languages, integer types unsigned, represents unsigned data types. Scripting languages often just have one integer type. Python has an integer type and a long integer which can get as big as it's need to. First one, representing integers. Can convert positive integers to base a signed integer value is representing in a computer by a string of bits with leftmost bit representing the sign. Integer types are directly supported by hardware. Signed magnitude notation. Sign bit is set to indicate negative and remaining bits represent the value of the number. Two's complement notation is used to store negative integers. Two's complement is formed by taking the logical complement of positive version of the number and adding 1. Representing negative integers. Two's complement To get the binary representation, take the complement and add 1. Second one, floating point numbers. Model real numbers but only as approximations. In floating point numbers, expression can be in real number but it represents the approximation of the real number. Languages for scientific use support at least two floating point types, sometimes more. Usually exactly like the hardware, but not always. Some languages allow accuracy specs in code, example ADA. The collection of values that can be represented by a floating point type is defined in terms of precision and range. Precision is the accuracy of the factorial part of a value, measured as the number of bits. Range is a combination of the range of fractions and, more important, the range of exponents. IEEE, the Institute of Electrical and Electronics Engineering, floating point formats, single precision, double precision. Next, complex. Some programming languages supports a complex data types, for example Fortran and Python. In C and C++ language cannot support complex numbers, but Python and Fortran languages supports complex numbers. Complex values are represented as ordered pairs of floating point values. In Python, the imaginary part of a complex literals is specified by following it with a j or j, for example 7 plus 3j. 7 is real number and 3j is imaginary number. Next, decimal. Decimal data types stores a fixed number of decimal digits with the implied decimal point at a fixed position in the value. These are the primary data types for business data processing and are therefore essential to COBOL. C hash and F hash also have decimal data types. Decimal data types are stored very much like character strings, using binary codes for the decimal digits. These representations are called binary coded decimal (BCD). Advantages of data types: accuracy. Disadvantages of data types: limited range, wastes memory. Next one, Boolean types. Their range of values has only two elements, one for true and one for false. They were introduced in ALGOL 60 and have been included in most general purpose languages. Design languages designed since 1960. Boolean types are often used to represent switches or flags in programs. A Boolean value could be represented by a single bit, but because a single bit of memory cannot be accessed efficiently on a many machines, they are often stored in the smallest efficiently addressable cell of memory, typically a byte. Boolean types means Boolean expressions. In Boolean expressions, whether the condition true or false, check whether the condition is true or false. In Boolean types, we have only two elements, true or false. Next one, character types. Character is a symbol in programming language that has meaning. A character can be any letter, number, punctuation marks, symbols, or white space. For example, the word character consists of 8 characters and the phrase hello world consists of 12 characters including the white space and exclamation mark. In programming, character is a data type. We can declare a variable as of a character type and store characters in the variable. For example, in C and Java, we write characters when storing in a variable must